So, John.
All right, cool. I think mine's going to be a little bit along the lines of the last two talks, but kind of a little more chemistry based, a little more on the fundamental level in this. Started off, I'm a PhD student at Arizona State. I work with Sarah Walker. Happy to talk about any of her work too later on. And I know Stephen Jay Gould has come up a lot in the last couple of days. I'm going to do that as well, but say that one of his themes that I particularly take offense to is that you can go back to the beginning of evolution and you'll end up with something entirely different. I'm not arguing they're going to have bipedal, intelligent humanoid things, but the chemistry I'm arguing is going to be relatively the same. And I think the reason for that is I look at life as a chemical property and a biosphere level property. So I think you can't separate looking at life. I think you can represent the word evolution here as well, and that you can't separate evolution and life without looking at the entire biosphere and without looking at the chemistry behind it, because it gives it a potentially universal way of looking at it and also a quantifiable way of looking at it. You can quantify the chemical reactions. You can say that there is chemistry throughout the cosmos. And those kind of properties I'm talking about are things like chirality, which I did a little bit of results in the talk I had online. I'm not going to go through them here. Things like molecular weight, things like elemental distributions. And then if you want to abstract things out a little bit, looking at network measures, this thing called complexity, which I'm not going to even try to define. I think it in terms of a network property, but use your favorite definition for complexity here, but make sure you have a definition. But those things can be applied to kind of chemistry metrics. And eventually, if you kind of build up this kind of chemical properties across different ways we look at the world, one being like the stuff we see non-living in the geosphere, things we see living in the biosphere, and things we see things that we as humans can make. You get pretty simple stuff in the geosphere. Yes, there's like things that are difficult to make, but life is, again, looking at more of a network measure, life is more complex. There's lots more interconnectedness. There's lots more evolution. And we can do a lot of weird things. We can do drug chemistry. We can explode atom bombs. We can do a bunch of stuff that's in here. But biology, I would argue, has a lot of these kind of properties with a very limited amount of elements that they're using. So what kind of makes us special? And kind of think the ultimate questions that we have is that this isn't a limiting property, this is a predictive property. And we can say, what can future chemical exploration look like here on Earth? Like, what are we as living things going to eventually use as biochemistry in the future? And then also, can we use the kind of properties we see here on Earth to say, life looks like this with these biochemical properties elsewhere? And yeah, I will end it there. Twitter and email are here already. One person's already reached out to me, so thank you. If you want to continue this outside of this particular conversation.
Okay. Jason, I'll call on you first.
Yeah, just a question. I mean, so even so thinking about replaying the tape, as you said, it would turn out somewhat similar here against Gould. The move from prokaryotes to eukaryotes, I mean, someone can probably know this better than I do, but it took something like 2 billion years. So the idea, the move to multicellularity here strikes me as completely contingent arbitrary. So perhaps simple single-celled organisms may be a factor of a complex planetary environment, but I don't think I don't think there's any more convergence than that. Or let's put it this way: once if we get to multicellularity, maybe we start to see convergences there, but there's no necessity that things have to get to the cellular level. And if that's true, I mean, it seems like this brings in a great deal of contingency into how we might think about the universality of evolution and issues of complexity and things like that. But I just wonder what your response would.
Yeah, I think I would argue that it most likely would happen. I think the argument for it is that when things became more complex, there's a lot more potential chemistry available. There's a lot more space to evolve into. There's the space to explore. You can only get so much energy. You can only get so big if you're a unicellular organism. If you're multicellular, all of a sudden you have a bunch of other options. And I think I would argue, I think intelligence gets a little weird because you can't really define it. I think there's a lot more that we could explore as intelligent beings. So I'd argue this kind of chemical space exploration. I think
right. I don't want to monopoly. So just one quick kind of follow up. But I mean, to me, 2 billion years might as well be arbitrary. I mean, that is such a gigantic kind of scope of time that if it takes that long for things to ramp up, I guess for me, I have a hard time understanding how kind of things like this likelihood or necessity or probability begin to fit in, since that's such a large period of time. Even if things are getting more constrained over time, I guess, for me, I just I guess the bottlenecking here, I guess I have a little bit of trouble with.
Yeah, and I would agree. It certainly is a long amount of time. This is where I think I'll resort back to some almost a great filter argument of there are steps that are difficult to take. But once you get past it, you can definitely go out and kind of fan out larger. And I certainly argue that it's difficult. I think given enough time, given enough possible repetitions, until the evolutionary step like this would have a number of advantages and argue probably would happen again.
I have a suggestion.
Yeah.
The 2 billion years may have been required for the bacteria to make enough oxygen for there to be an environment that eukaryotes can live in.
Thank you. That's helpful.
Okay, Eric Pearson.
Yes, you said you wanted to define life in terms of chemistry.
Mhm.
And well, I have a whole lot of issues with that. But first of all, I don't think you need it for your claim about going beyond SSoCIA goals stuff. In fact, I think it would make it even more interesting if you said that you define life in some other terms and you make an empirical claim that you need a certain chemistry to achieve that.
Mhm.
But I also want to ask, like, if you go to some world, this is a standard objection. If you go to some world and meet something that walks around on 2 legs or 4 legs and is obviously intelligent and sentient and looks back at you and communicates with you, and it doesn't have this chemistry, would you say it's not alive?
Yeah, I would certainly say it's alive, and I would say that I was barking at the wrong tree for however many years I studied this. Yeah, I think certainly, I think it's certainly a tough problem to define life like this. And I think we're very limited in saying, in just looking at the end of one problem. I do think there is certain patterns that we do see in these kind of properties that are interesting enough to say this could be universal. And I think the big claim I'll put on all of this is, yes, this is an n = 1 problem. And if you find something that walks and talks and communicates, and is based on some entirely different chemistry and uses an entirely different system of energy and everything like that. Yeah, I'll 100% redo all of this, but for now I'll operate under the assumption that hopefully it's universal.
But then it sounds like you're making an empirical claim about what is necessary to be alive, not the definition of life. A claim about what kind of chemistry is necessary to, is practically necessary to be alive.
Yeah, I think the structure of chemistry and the properties, yeah, I am basing it off that instead of chemistry itself. Yeah.
Okay, Lucas.
Thanks. I love these questions. About 15 years ago, I tried to come up with the actual distribution of atoms within stars, within rocky planets, and within the biosphere. And it turns out those are really difficult questions to answer.
Mhm.
But I feel like it would be a more convincing argument if you had that distribution, because plutonium is relatively rare in the Earth, in the geosphere. And it's the lower elements that make up the vast bulk of the planet. So have you given any thought to those distributions beyond your sort of broad bubbles on that diagram?
Yeah, I know something we've been using is a drug database, Pre-Access, if anyone's familiar with that. It has, essentially, it's a mix of all pharmaceutical companies, potential like random chemistry that chemists have made over time. And every single element is in there. And we've looked at distribution of where those elements kind of line up. Surprising amount of lower metals. Go ahead, yeah.
So, I mean, that's awesome. I meant more your diagram that had the 3 circles,
Yeah.
the geosphere, the biosphere, and the technosphere. Because I think that the composition of the geosphere is more complicated than you're giving it credit for.
Mm-hmm. No, that's fair. I think I'm more looking at the interactions between these compounds, interactions between these elements. Just having a hard time putting a network onto this kind of graph. And I think the interactions between life and interactions between the technology that we make are robust in a way that looks very different than a geosphere. Yeah, and I think that that's the measure I was using when I made those initial bubbles. Yeah.
Okay, Carlos.
Yeah, thank you. John, we should talk at some point. I think that you actually disagree with Stephen Jay Gould less than you think you do. It's a little bit hard to tell because Gould gives many different justifications for his claims, and it's not entirely clear that he's being consistent from page to page. Stuff that I've written on, and I can point you in that direction. But he does allow for certain, like he allows for like symmetry to be a universal property. He allows for all sorts of things to be universal. He just doesn't think that those are the things that biologists care about, which is like a social claim. And I'm not sure I don't even know how to assess it. But anyway, just a comment.
Yeah, no, thank you. I appreciate that.
Okay. Eric H., did you want to ask a question?
No, I just
Okay.
had my hand up because I'd forgotten to click the button.
All right, is there anybody else that would like to ask a question or make a comment? Okay, in that